Our new topic is probability. Oops. Okay, so there are a number of vocab words you just need to know. We talk about the number of possible events or outcomes, and a sample space is all the possible outcomes. So for instance, if you're rolling a dice, then the events that you can get, the actual outcomes for rolling a dice, are all the numbers on the dice. So you can go 1, 2, 3, 4, 5, and 6. And because they're all the possibilities that you can get from rolling a dice, they represent the sample space. Now, to calculate the theoretical probability of an event occurring, like for instance throwing a 2 on a dice, it's the number of times that the event occurs divided by the total number of outcomes. So the probability of throwing a 2 is 1, because a 2 only occurs once, divided by 6, because there's 6 different outcomes. Probability, the value for probability always lies between 0 and 1, where if probability is equal to 0, then it means that the event can't happen, and if the probability is equal to 1, then the event definitely will happen. And normally we record probabilities as fractions or decimals, and sometimes as percentages. You can also calculate how many times an event would be expected to occur if you repeat a trial for a number of times. You just calculate, you just multiply by the number of trials. So the probability of throwing a prime number on a 6-sided dice. Our prime numbers are 2, 3, and 5. So the probability of throwing a prime number, we've got 3 possible outcomes over a sample space of 6. So the probability of throwing a prime number on a dice is a half. Now, the number of prime numbers we would expect if we rolled the dice 10 times is simply the probability of getting a prime number, which is a half, times the number of trials, which is 10. So with 10 trials, we'd expect to throw 5 prime numbers. Okay, now not always probability is easily determined, in which case we need to actually do experiments to determine the relative probability. And the important thing to remember about this is that the larger number of trials that there are, the more likely the relative or experimental probability is to be accurate. So let's look at this question here. The table shows all the different coloured cars that entered a school gate on a particular morning, and to estimate the probability that the next car will be red, we simply use the data that we already have and assume that it is a representative probability. So the probability of a car being red is the number of red cars, which is 45, divided by the total number of cars, which is 138. Okay, now the next day, 350 cars come in, estimate the number of red cars. So this is just simply going to be, so we're looking for the number of red cars. This is simply going to be our probability for red cars, which we worked out the day before, times the total number of red cars, of total number of cars that occur, and this is 114.13, but we're just going to round it to a whole number. Okay. Now, Venn diagrams are often used as a strategy for solving probability questions. So you need to be able to work between the vocabulary of the two, between Venn diagrams and probability. So the sample space in a Venn diagram is the universal set, and it's this square rectangle, that we always draw around our diagram. An event A is represented by the set A, a circle inside a universal set. And so this here is set A, and the other thing that we can talk about is the complement of an event, which is everything that is sort of not in A. So in this case, the complement of A is everything that is around it. So, and this is written with an A dash, represents the complement. Okay, and obviously if an event either happens, it's inside set A, or it doesn't happen, it's in the complement. So the probability of those two things always equals 1, and you can calculate the probability of a complement by subtracting the probability of A from 1. So those two formulas there are quite useful. The other thing that you need to know is the notation for intersection, which is this upside down U. The intersection of set A and B is everything that occurs in both A and B. It's that area there. And the union is the other thing that you're going to see. This has the symbol is what looks like a U. Union is everything that's in set A or in set B. And notice that it includes those things that are in both. So that's union and intersection. Okay, so let's look at a typical question. Okay, so the Venn diagram shows students taking either math studies, German, or music. Yeah, so find the number of students doing none of those three subjects. So this is the complement of everything of the union of the three sets. So it's this number here, it's 73. Okay, music and German, but not math studies. So this is going to be these numbers here. It's 9 plus 6 plus 13, which is 28. Music or German, but not both. So here's mine who take music and German, but not both. So this is 3 plus 13 plus 8 plus 9 is 33 of those students. Math studies or music, but not German. So the other ones that are taking math studies or music, but not German, it's 22 plus 3 plus 13, which is 38. Okay, and then finally, all three subjects, which is the X in the middle, if there are 136 students in the sample. So it's simply 136 minus all the other values. So 73 plus 22 plus 8 plus 9 plus 6 plus 13 plus 3, which is equal to 2. Okay, here's another question. In a class of 30, 15 own a bicycle, 10 have a car, and 2 have both. Draw a Venn diagram. Okay, now in questions like this, always start with the middle. So the first thing you're going to write down is the 2. Then you know that 15 own a bicycle. Well, we've already got 2 of them down, so that means 13 have a bicycle who don't have a car. We're told that 10 have a car. We already have got 2 of them there, so there's 8 left over there. So, question A, a randomly chosen student owns either a bicycle or a car. So this is the probability of bicycle union car, which is, we just simply add up all those numbers. 13 plus 2 plus 8 is 23 over 30, because there's 30 students in total. Okay, and then B, probability that a student owns neither a bicycle or a car. So this is the complement. So the probability of P union C complement is simply 1 minus 23 over 30, which is equal to 7 over 30. And we can actually put that 7 in there. Okay. Now, addition rule. So for any, this is a very useful formula, it's in your booklet, to find the probability of any one of these things, we can use this formula. So it's the probability of the union of A and B is the probability of A plus B minus the probability of the intersection, because you don't want to count those numbers twice. So let's have a look here. You can do these questions in 2 ways. You can use a Venn diagram, or you can just substitute into the equation. So we have, so the probability of A union B is 0.7 is equal to the probability of A, which is 0.6, plus the probability of B, which is the thing that we're trying to find, minus the probability of A intersection B, which is 0.3. So we've got 0.6 minus 0.3 is 0.3. So we've got 0.7 minus 0.3 is equal to the probability of B. So probability of B is equal to 0.4. Now let's look at how we could use the Venn diagram to solve this. We know that the intersection, we always do that first, is 0.3. So I'm going to write 0.3 here. Probability of A is 0.6. So I've already got 0.3 there. So there's going to be another 0.3 here. And the union of A and B is 0.7. So I've got 0.3 plus 0.3. So this one has to be 0.1, and my probability of B is those 2 numbers added together. 0.3 plus 0.1 is equal to 0.4. Okay, so same thing for this next question. I'm going to solve it using a Venn diagram. You could otherwise simply substitute into the formula. I prefer to use a Venn diagram where I can. Okay, A, B. Okay, so always start with the intersection. This is 0.2. Okay, I know that my probability of B is 0.3, so that's got to be 0.1, and my probability of A is 0.6, so this is going to be 0.4. My first question is probability of A union B. Well, I'm simply adding up all these numbers, so it's 0.7. B, probability of the complement of B, so B, so this is 1 minus 0.3, which of course is 0.7. And C, A intersection B dashed is 0.4.